Hi everyone, welcome to the first video lesson for the back half of Math 117. So today what we're going over is an extension of what we were talking about before the suspension of the classes, our metric conversions. We're going to review what we talked about and then add on and talk about how we can convert areas and volumes as well. So the first thing we should remember is that we're going to be using something called the unit factor method for conversion. The nice thing about the unit factor method is that if we're converting from something like kilometers to centimeters, then maybe we don't know the conversion factor that lets us go straight from kilometers to centimeters. We can link different conversion factors that we know together to do the conversion. So hopefully I know that 1 kilometer is 1,000 meters, and 1 meter is 100 centimeters. So if I want to convert 0.0156 kilometers to centimeters, I can set up my conversion factors so that my units cancel. That means I'd start with kilometers in the denominator because that's my starting unit, and then it would cancel, and then I could go from meters to centimeters, and I'd set up my conversion factor. 1 meter is 100 centimeters. So again, my units cancel, and I know that to do my conversion, I'm going to multiply by 1,000 and then multiply by 100. So my final result is that 0.0156 kilometers is equal to 1,560 centimeters. As I'm going through these videos, make sure that you pause them at any moment, at any point in time, and try the calculations yourself. And if you have any questions, don't forget to drop into my WebEx room to ask for clarification. So before the break, we talked about memorizing all the standard prefixes between kilo and micro and memorizing them. You will notice up on our D2L shell that there is a sheet of conversion factors posted. And this sheet of conversion factors is going to come in really handy in our next unit. It has all of our conversion factors between our metric and non-metric units and between our non-metric units. But up at the top, there's also a quick summary of the relative size between the units between millimeters and kilometers, or milliliters and kiloliters, and then milligrams and kilograms. Okay, there's an extended chart for the metric system on the second page, and so that can be useful. We could, using this chart, maybe see that there's 1, 2, 3, 4, 5 powers of 10 between kilo and centa. So another way to do that first question would have been to say 1 kilometer is equal to 10 to the power 5 centimeters, and then we could set up our initial measurement with our conversion factor. We would put 0.0156 times 10 to the power 5 into our calculator, and it would still come out to 1,560 centimeters. Okay. This technique of counting relative steps is really handy in the next example when maybe we're less familiar with deciliters and the size of deciliters compared to milliliters. So if I go to my conversion chart, I can see deciliters to, what size is it again? We're going to milliliters. So deciliters to milliliters, it's 1, 2 steps. So there is 1 deciliter, it's larger, so we're going to say there's 1 of it, and then there's going to be several milliliters to make 1 deciliter. So 10 to the power 2 milliliters in 1 deciliter. So to do our conversion, we write down our initial measurement, and then we would set up our conversion factor so that the deciliters cancel. So we're multiplying by 100. So 2,658 deciliters is going to be 265,800 milliliters. Okay. Another feature you might notice on this chart is that when it comes to the mass units, in addition to our different types of grams, we also see a metric ton show up. A metric ton, spelled T-O-N-N-E, is equal to 1,000 kilograms. And so if I want to convert from 0.067 tons to grams, right, I might use the fact, so 1 ton is 1,000 kilograms, and 1 kilogram is 1,000 grams. So my conversion from tons to grams, again, I would be, in this case, multiplying by 1,000 and then multiplying by 1,000 again. It just happens in our examples that we're always going from larger units to smaller units, and that doesn't have to be the case. Okay, when we plug that into our calculator, then that calculation is going to come out to 67,000 grams. Again, those examples should be relatively familiar to you. We looked at those in the other Module 9 practice, and if you're looking for extra homework related to those, look at the other Module 9 metric conversion notes. So what we want to add into the story today is how we can calculate different types of area units. So distance, all of our distance measures like centimeters, meters, millimeters, measure length. Area has 2 dimensions, right? It has a length and a width, and it's always measured in square units. Okay, in order to convert an area measurement, we have to use the square of our conversion factor. Okay, this will be true whether we're converting metric units or non-metric units. The nice thing is that because our metric conversion factors can always be expressed as powers of 10, when we square the unit factor, we have a little bit of a shortcut to figure out our new conversion factor. We can always just double the exponent if I write my conversion factor in exponential form. So if I want to convert from meters to kilometers, right, I'd start by thinking about, well, what's my standard conversion factor between meters and kilometers? Well, I know 1 kilometer is 1,000 meters, so 1 kilometer is 10 to the power 3 meters. Because I'm converting an area, 1 square kilometer is 10 to the power 6 meters squared, right? So I'm squaring the conversion factor, okay? Because it's a power of 10, my shortcut is I can double the power of 10. Once I know my conversion factor, the rest is simple. I write my initial measurement down. Next to it, I write my conversion factor. Okay. My units cancel, and so to do the conversion, I'm going to write my initial measurement into my calculator, 7,550, and then because of the location of the value that's not 1 in my unit factor, in this case I'm going to be dividing by 10 to the power 6. So I do 7,550 divided by 10 to the power 6 in my calculator, and the result comes out to 0.00755 kilometers squared. You can write this in scientific notation if you want, okay, whatever makes more sense to you. But we're going to have the measurement component, and then we'll have the unit at the end. Okay. if I'm going from centimeters square to hectometers, again, my first step is to think about how do centimeters and hectometers relate. If I'm not familiar, I might pull up my conversion chart and say, okay, hectometers are bigger than centimeters. How much bigger? They're 1, 2, 3, 4. They're 10 to the 4 times larger. So we know 1 hectometer is 10 to the power 4 centimeters. So 1 square hectometer is 10 to the power 8 square centimeters. Okay, got my conversion factor. Next thing I do is write up my conversion equation. My initial measurement with units, next to it, my conversion factor. In this case, I'm going to be taking my initial value and dividing by 10 to the power of 8. I'm going from a smaller unit to a bigger unit, right? And that's also how I set it up so that the units cancel. So when I do that, it comes out to 0.0145678 hectometers squared, or 1.45678 times 10 to the negative 2 hectometers squared. Remember, as you're going through these lessons, to pause at any point to be able to do the work alongside and check your results. Okay, the next thing that we're going to consider is volume units. When we're dealing with volume, it's nearly identical to when we're dealing with area. The only difference is volume is in 3 dimensions. So we have a length, a width, a width, and a height. Okay, and so our conversion factors, our standard distance conversion factors, have to get cubed in order to account for these 3 different dimensions. Okay, when we're doing metric conversions, if we express our conversion factor as a power of 10, then when we cube the power of 10, our shortcut is we can triple the exponent. So if I want to convert between 2,500,000 cubic meters to cubic kilometers, I start with my basic conversion factor. 1 kilometer is 1,000 meters. I can express that using powers of 10. 1 kilometer is 10 to the 3 meters. And so then I know 1 cubic kilometer is 10 to the power 9 cubic meters, right? Because it's cubic, I triple the exponent. Okay? With that rule in hand, using my unit factor method, I write the original measurement down with units, and next to it, I write my conversion factor that lets me go from cubic meters to cubic kilometers. Okay, cancel out my units, and so I know that I'm going to write 2,500,000 divided by 10 to the power of 9 in my calculator. Okay, that should come out to 0.0025 kilometers cubed. Okay, pause the video and try the following 3 practice questions. Okay, the answer should be as follows. For the first question, you might want to write it in decimal form or scientific notation. For the last 2 examples, an answer in scientific notation really is better given the size. Okay, the final thing we should mention when it comes to metric conversions is water. So water is the base for converting or for relating mass to volume with metric conversions. 1 milliliter weighs 1 gram because the density of water is 1 gram per milliliter. With this in mind, we can convert volumes of water to masses. We'll have to do multiple conversion factors going from liters to milliliters to grams, but it's fully possible. I'll continue this in a second video because my maximum recording time is 15 minutes, and that's just about it.